Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 21 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3315. Construct the minimum bitwise array part 2. So yesterday we have solved part 1 of this problem number 3314. So in this part 1 I have explained you two approaches. One is brute force and second one is optimized one. So let's first see what is the difference in part 1 and part 2. So difference is this, the constraint size for this nums of I value. So in this constants, if you see, nums of I value is from 2 to 1000, but in part 2 if you see the constant, this constant nums of I, so it is from 2 to 10 power 9. So in brute force what we were doing, so let's suppose if your number is 1000, so you are checking numbers like this 0 or 1 and just checking if it is equal to 1000, then 1 or 2, then 2 or 3, then 3 or 4, like this you are checking all the numbers, and this solution was accepted. So if I just show you the code of part 1, so this is what you are doing, right? So here you are just iterating over your list and you are just taking that one particular number, and then after that, if we don't find any value with where answer of I or answer of I plus 1 equal to nums of I, then we are just returning -1. But after that we are just checking the candidates like this 1 or 2 if it is equal to original, then 2 or 3 if it is equal to the number, like this we were checking. So if I just copy this code and paste it in today's problem part 2, so this is just brute force, right? So if I just submit it, so this solution will not be accepted, so it will give you the time limit exceed error. So see here, 610 test cases got passed out of 776, but in part 1 we were able to pass this solution with time complexity nothing but m into n, because here if you see this nums.size, so here I'm running one for loop for m times, and here I'm running one loop for, let's say, n time. So this is nothing but the original number. So original number can be from 1 to 1000 in part 1, but this number is very big in part 2, so that is why this brute force will not work. So in yesterday problem itself I've explained you the second approach, the optimized one. So in optimized one, what we were doing, so let's say your answer of I value something like this, maybe 1001. So in binary form, this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8. So when you are going to add 1 to it, so what is the next number you are going to get? You have to add 1. So in binary addition, you know that 00 is going to give you 0, 10 is going to give you 1, 01 is also going to give you 1, and if you do 1 1, so it is going to give you 0 but with carry 1. So here 1 plus 1 0 with carry 1, so here I will get 1, and here I will get 0, and here I will get 1. So this is nothing but your answer of I plus 1 value. Clear? So now let me just remove it. This is clear, this is done. Now if you do the OR of these two, if you do the OR of these two, so then in that case what you are going to get, you are going to get your nums of I value. So in this case the nums of I value is going to be 1 1 0 and 1. So if you read this in a decimal form, it is nothing but 9, and if you read it, it is nothing but this 10, and this is final nothing but 11. So here now if you read this is 11, right? So in this 11, just notice one thing. So here you have 1 and here you have 0. Clear? And everything else, if you see, here you have 1, here you have 1, here you have 0, here you have 0, here you have 1, here you have 1, everything else is same. So only this is what is getting changed here in this part. Clear? So what you need to do, so yesterday I have explained that first you need to check this, if it is 1, then move to next one. If this is 1, skip. If this is next time, if you move here, and if this is 0, so in that case whatever the next bit after this, that is going to be 1, just change it to 0, and that is going to be your output. This is what I have explained yesterday, right? So here if you see this, I have given you a lot of examples in the optimal approach. So you can just watch this video 3314 for detailed explanation of approach 2, but this is what we need to do. Let's go to this part 1 of this problem, and here submissions. So yesterday I have submitted this is optimized code, I think. So let me just copy it to editor. So here, this is your optimized approach. So let me just go here in part 2 of the problem and just paste it here. So in this, again, you are going to get first target you are selecting, then answer you are selecting as -1 if it is not if it is impossible default, right? So that's why I have to return this. Then bit mask, it is start from the least significant bit, and then after that I'm just going to do target and bit mask. If it is not equal to 0, then answer is going to be target minus bit mask, right? So this is approach 2. I've explained this approach clearly step by step in this. You can just watch it. So now let's submit this code. So this will be accepted. So see, our solution is accepted, right? And in this, the time complexity here, let's say this is running for O of n times, and this after this part, it is just going to run in the logarithmic time complexity. So O of n into, you can say, log of max of any nums value. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys next video. Thank you. Bye bye.